all, I'm a very bad English speaker. So, but I am a good French speaker. As to say in France, we found the answer in say, loin du français je meurs, far away from French speaking, I will die. Okay? So I am a Linux developer, writer and teacher, and I work for a company in Paris, which is called Slide ECS, or the Integrated System. And I wrote some books, and the last one is this one, Linux and Marketing, means Linux in French. A quick story for Yocto. It's quite an old project, started as Open Embedded with OpenZorus, because this boot was not starting up at this time. It's much better today. And it's based on recipes. The recipe is how to cross-compile X for a target Y. And there is a tool named Gmake, which is kind of Gmake, much better than Gmake, but it's quite the same thing. To run Open Embedded recipes, and it was inspired by a portage from Gen 2 and written in Python. And the Yocto project itself started in 2010 by Intel with Open Embedded, including lots of the projects including Open Embedded, Debate, Poppy reference distro, GDC, and a very good documentation, which was not the case before. Before Yocto, there was no documentation. The documentation for Open Embedded was everywhere there was a freedom to belong. So now there is a very nice book with 400 pages and lots of books around the project, so it's fine. It's quite complicated to use, but you can find all the variables in the documentation. It's like Android, because Android is quite complicated to modify and use, but you have no documentation. Except some books from before, but quite nothing from Google. So is an excerpt of documentation with Yocto layer. So when you get Yocto, you get these two layers, and you can add any layer you want, and you can add a layer for your own applications or extensions. For example, we will talk about ZenLive, which needs a specific layer, because it's quite complicated if we compare with the official preamp. So some principles based on recipes. You can extend recipes. We talked about it during the presentation. You can use classes. You have configuration files, include files. Everything should be in the meta, in a layer actually, meta whatever. And there is a very few number of baseline targets. That was not the case for Open Embedded. So it was a real problem. And with Yocto, you have only 2 targets, bigger than black, one PC board, generated x86 and an edge router. I didn't use the edge router, but it's and if you want to add a new platform, such as Raspberry Pi, you need to add a Midas BSP data layer. So if you want to compile Yocto for the P3, for example, you get the local distribution. Actually, it's Yocto with Open Embedded, etc. You can get the Meta Raspberry Pi layer. To create a big directory, you add the Meta Raspberry Pi layer. You define the machine, and then you build a simple image, which is called image micro. And you create a micro SD, and so you have Yocto running on the board. It's quite simple. Now, if you want to use real time, it's much more complicated because actually there is an official support for preamp30 in Yocto, but it's quite difficult to use, and I don't know if it is really useful. You will see why. So there are several talks about Linux and real-time at FOSDEM. So there are two ways. The pre-30 project, which is a single kernel patch, very easy to install. And Xenomide, which is a co-kernel approach with the Cobalt. And it's a kernel patch, which is called IPy, and some libraries and tools, etc. Actually, for Xenomide, there is a user space part, and for pre-30, you can use the standard user space part. It's the main difference. With the new Xenomide 3, you can work on top of pre-30, it's called Mercury, but I think it's from a specific version from NEXT, which was called Xenomide Solo, and now it's called Mercury in the main line of Xenomide. But most of people use Cobalt because it's much more efficient. So pre-30 is the official Linux RT patch. RTI was a fork for RT Linux 3 when it was free. Now it's dead. It was free today. By Paolo Montecaza, and Xenomide is the fork of RTI by Philippe Géron, who is a French developer, a very famous French developer in the RT ecosystem. So the co-kernel is more complex to use, but it is much more efficient. If you, at least it's about 2 times more efficient. It could be more, depending on the configuration or the quality of the patch. But it's a bit difficult to use because the hardware support can be a bit tricky to set up. There is a specific kernel interface for the drivers, which is called RTDM, because it's a specific kernel. It looks like Linux drivers. But if you have a Linux driver, you have to import the Linux driver to RTDM. And there is application design could be some difficult because of the migration program. Actually, on Xenomide you have two domains, one for Linux and one for Xenomide for the real time. And if you call some system calls from the Xenomide, Linux system call from Xenomide, you will lose the real-time capabilities. So it's a real problem. And if you have a big program, it could be very tricky to develop. So, RT and build systems. Yocto and Beerroot are build systems. It's very easy to build RT image in Beerroot because it's included in Beerroot. Pre-30 is a single kernel patch, so you have just to configure your kernel and to say the kernel patch is here with the configurator, graphical configurator. And Xenomide and RTE support was been available for a long time, so it's quite simple to install. For Yocto, there is a dedicated kernel recipe for the Linux Yocto kernel, which is for Linux Yocto RT, with a dedicated image core image RT, with a, depending on Linux Yocto RT, it's just this, there is only one dependency on the kernel plus adding RT test, which is a set of tools for testing real time. But if you check the recipe, the compatible machines are linked to Linux systems, which is not the choice for real time. So we can say just for test, for testing and integration of the pre-30, but it's not really for using real time. For Xenomide, there is a support in Italy LDK from NEXT, but it's quite old, and so well, it's not very useful today. And it's dedicated to ELDK, which is a specific distribution from NEXT instead of copy. Well, so in Yocto we have a very interesting functionality, which is expanding recipe. So you update the recipe, which is a DB with a DB happen. And the most simple example is a splash screen. There was a default splash screen with open embedded logo. And in the new Metamoki, there is the same recipe with a DB happen and a new logo, which is the Yocto logo. So it's quite simple to to change files, to add files, to define new functions. For example, this recipe, extended recipe, activates the I2C bus on the Raspberry Pi because it doesn't activate the Pi before. So we can use this system for preempt30. Preempt30 is very simple because you have just to patch the kernel. So we create a new layer with the test name, and you add a recipe for the kernel with an extension of the recipe. So you have to define, of course, the path for the patch, patch. Configuration file, which is always a defconfig file in the standard Linux Yocto kernel, and a media plan with only lines such as this one, except the copy because it's not dedicated to copy. The preempt30 kernel branch is available from some boards, so you don't have to apply the patch, you don't have to get the commit for the RT branch. For example, the bigger black, there is a branch for preempt30. But it's much more complicated for Xenomile because you have the two parts of Xenomile, so we have to develop a specific layer. This one is not really a specific layer, it's just an extension of the kernel. Just one word about Meta Raspberry Pi, that there is a Linux kernel, of course, in Meta Raspberry Pi, but it's not really compatible with the extension, so you have problems if you want to apply fragments or extension. So I wrote a new recipe for Linux Raspberry Pi kernel. But it works only for P3, and the standard kernel works for all the type of Raspberry Pi. So the Xenomile is difficult as you have to patch the kernel with a specific script, which is called prepar kernel. It's a patch, but it's set settings between 5, so you have to, it's a procedure for Xenomile. And you need to install the space file. It's based on Yocto, but you have to do that. There was a GitHub Xenomile layer, something on GitHub that was really updated, out of it. So I got the current GitHub Xenomile. And I create a new Linux Xenomile dashboard. Actually, it's only for Raspberry Pi 3. And the user space recipe, which is based, so it's quite simple. The most difficult part is to have a specific function to patch the kernel, to run the prepar kernel before configuring the kernel. It's only for Cobalt, of course. And this function is executed before configuring the kernel with the add task. So the best way is to show you the code because on slide is not really that simple. Okay. So you have the prepar kernel function. So you run the standard procedure for installing the Xenomile, patching the kernel. You call prepar kernel, and you say to Yocto to be baked, then you will execute prepar kernel after the do patch, after patching the kernel, and before configuring the kernel. So it's quite simple when you have the function. And the difficult part in Xenomile is to get the right patch because if you have a specific board with a specific kernel for BSP, you need to get the right patch to run with Xenomile. So you have to adapt the patch. So the recipe is not the most difficult part of the work. The most difficult part is to get the iPipe core patch working. You have to configure Yocto file, or you can create a dedicated image recipe. So you need to use a preferred provider command from Yocto. So you say preferred provider virtual/kernel is normal. The virtual/kernel recipe is the name of the kernel, the default kernel. So you say to force the default kernel to the normal kernel. And then you have to install, of course, the user space part, which is the normal recipe. This is quite simple. It's just user space. So I can show you the recipe, but recipe 09. 09. So you just have to inherit from Yocto and create something and some options. You have to for the PI recipe. For Raspberry Pi, you have to enable the ACP and for the products, but I think it is the default. And you can build a specific image. So you save the kernel, the kernel. Just one thing about the P3. The P3 Pi3. The Pi3 is quite specific because the default UART is used by the Bluetooth. So you want to say I use a fake UART, it's a kind of UART, but it's not an official UART like on the previous Pi. But it doesn't work with the domain. I don't know why. It should be a problem with real time. So you have to force the standard UART. You don't have the Bluetooth, but it's not important for real time. So you have to force the default UART, hardware UART to use the domain. And to get the console. If you use the graphical screen is okay. But I don't use graphical screen most of the time. So I like my console. Okay. There are some work to do because I didn't test on recent version of Yocto. We not so difficult to do. And to test on new boards. But most of the time it's done by end user. So you can get the recipe from the domain. And just to have to change the batch, just to modify the recipe to match your kernel edition, and it should work. I have some customers using the Raspberry Pi. I didn't know that, but they say, some time ago, I use your layer for it's quite simple once you have these recipes. I can show you a simple demo. Better with the demo. Okay, so the first one is the domain. The second one will be preempted. It's quite simple. Just to show the latency you have with the domain compared with preempted. So I just did a simple script because most of the time we have SSH for starting. You can start the latency program on the console and start the Hackbench program on another connection. Hackbench is a tool from RTTest package to generate memory hard mode on the system, like making lots of threads, lots of processes, sending data between processes. So I will start the test. Okay, so I start the latency. So you can see the worst is 4 microseconds. So worst filter. And so when you start the Hackbench, you can see the worst case is about 25 microseconds. Okay? So Long time, of course, in a real situation. And if I change for 330, I just have to change the flash, the card. Difficult to get all. Okay, so it's the same board, but a different kernel because it's not the same patch. In model 4. And for so you have patch. You can start the cyclic test, which is still in the RT test. Okay? So the worst case is on the right, in microseconds. But the good way to test is to say, to start the Hackbench. But as we are on patient, we will stop the Hackbench. Okay, you can see the worst case. So it's a bit more than Xenomite, but it's quite simple to use, quite simple to install. When you develop applications, it's very simple, it's just like Linux, drivers and application. With Xenomite, you need, I didn't talk about it, but you need a dedicated SDK, Yocto SDK with Xenomite libraries. With a Xenomite script, which is xenoconfig. So, and you have to develop specific drivers. So it depends on what you need. If you need a standard real time, or a soft hard real time, you need FOSDEM. If you need a hard real time, you have to choose the right. Okay, that's it. If you have any questions? In English or French? Yes, lots of systems. Because Xenomite was developed by Jerome, and actually my previous company was Xenomite, and Jerome was an employee of Xenomite, so we worked lots of projects with Xenomite. Most of the time. Yeah, for example, lots of machines, industrial machines with cameras. You need. We had a project in Lyon. I remember it was a camera with to check anomalies on the piece of people, and you need to do that. It was based on those, so no problem with real time on those. But problem with network, so we switch to Xenomite to have a real-time camera. And there are also lots of projects in military projects. I can say a lot about it, but we have lots of customers using it. But we have lots of customers using FOSDEM, for example, Airbus and Dassault Aviation in France for planes. Systems they use FOSDEM because the FOSDEM is enough. If it's enough, you can use FOSDEM. But if you need real time, you use the domain. Thank you for the attention.